Okay, so we're going to continue going over 2.2. We're going to start at explore number 12. We did it already, but I kind of want to give you a couple more hints on how to approach a problem like this, because if you notice, it's the going backwards of graphing. So in math, we often ask you to go forwards, and then we'll ask you to go backwards. It's very classic math thing to do. We taught you how to add, and then we taught you how to subtract. That's backwards. That's the backwards of adding. And if that makes sense to you. Then we taught you how to multiply, and then we taught you how to divide. Then we taught you to square root, and so on. So graphing, first we'll teach you how to graph, and then we'll teach you how to go backwards of that. So right now we're in the land of transformations of log functions. That means basically, how do you take your basic log function and like do something to it, whether it be like, +4, like down here, -1, +2 times 4 divided by -1, all those. And then what effect does that have on the graph? Okay, so yes, you can pull out a graphing calculator to figure this out, but I'll be asking you questions during the tests, like, how did you know that? And I want to hear language that we've talked about. Well, it's a translation 3 to the left. For this one, it's 3 to the left, right? And that's how I knew it was x plus 3, because remember we talked about in X land, right? In X land, everything is backwards. They live in backwards land all the time, right? So whenever you're shifting anything from the left or the right, then it's backwards of what you think. Left 3 is +3. Right 3 is -3, right? Okay, so for this one right here, and I kind of want to blow it up a little bit because it's so tiny. I think that's better. So when I'm looking at this picture, right, I notice a couple of things. The first thing I notice is that the asymptote moved x equals to -3. Normally, our standard log function, the normal log function here, let me write it right here. So when I look at log base 2 of x, right? When I look at that function, the asymptote is x equals to 0. Okay, I know you can't see it yet, but right here. So what I want to show you, and the reason why I want to show you this is because it'll help you, is if I go log base 2 of x, right? Do you see how the asymptote is right here at x is equal to 0? Does everybody see that? And now if you look at this asymptote, it shifted to the left 3 times. This means left 3, okay? This means left 3, okay? Maybe make it a tad bit smaller so you can see all my writing here. All right, so does that make sense? Okay, so with that being said, that's how I knew that the function was going to be x plus 3, right? Because it shifted over. My first big clue is going to be my asymptote every single time. So that's what I first want you to pick up on right here. So I'm going to blow this up again. Look at this function right here, and I want you to look for the asymptote. Normally, our asymptote is at x is equal to 0. What is the asymptote here? What is the asymptote for B? In the chat, please. I am keeping track of your awesome participation. Please put it to the public chat. Oh, you guys are doing it to the public chat. I'll be quiet. Thank you, Miss Johnson. Awesome, awesome, awesome. I got a bunch of people seeing it at 2. Can you write x is equal to 2 next time? Because we want to capture the fact that it's x is equal to 2, not y. So just keep that in mind. It's okay if you already did it, no big deal. But we want to make sure that that is in our head, that we're talking about a line as x is equal to 2. Make sense? All right, moving on. So if you didn't know it was 2, your brain should be like, how come they got 2? Where'd they get 2 from? So you're looking for a line, like the line, that this thing is getting really, really close to, and it actually looks like it's touching it, but we know that it's actually not touching it. Here, the normal, like this is called the parent function. The parent function is at x is equal to 0. See how this red line is getting really, really close to it? Almost looks like it's touching it. In reality, it is not touching it. So you all said it's x is equal to 2. So let me just draw my little line in here. Let me draw it in this color. Right? Okay, that's at x is equal to 2. So I already know that my function has shifted 2 to the right. So because it shifted 2 to the right, now I'm going to make this smaller so you can all see. If left 3 meant plus 3, when I build this equation, what is it going to say in the parentheses? So let me just draw this out. Log base 2 of, and then put an x here. Yeah, it's going to say x minus 2. But Ms. Johnson, I thought it was just a 2. Why are you now putting it as a minus 2? Anybody remember why it's a minus 2? Why is it a minus 2? Why is it a minus 2? Why is this going to say minus 2? Let's see, let's highlight this with that. Let's see, someone says, because it went in the opposite direction. Exactly. Someone else says it's the function. If the function moves to the right, it's negative because x lives in backwards land. Exactly. Thank you for using my language. It's always the opposite direction when you're in the parentheses, and I'll explain it a little bit more clearly. It's always the opposite direction when we're talking about x because x lives in backwards land. Someone said it shifted to the right. And then someone else said because x will always be backwards. Okay, so exactly. And I'm gonna clip this so that you guys all see. Where's my little snippy tool? Okay, take this guy right here. And then put him right here. So this is my little note to you guys. I asked you guys a question. You guys came out with some fabulous knowledge. Scoochie over maybe. Yay, it fits. Okay, so if the function moves to the right, it's negative because x lives in backwards land. Y does not live in backwards land. Very good. Okay, so the next thing I need to do is so I also noticed that it kind of looks like it moved down a little bit. And if you don't know why I think it moved down, I'm looking at this point right here. Do you see this point right here, 1, 0? It's 1 away from my asymptote. It's 1 away from my asymptote. So what point are you looking at, Ms. Johnson? Well, 1 away from my asymptote is this point right here. Use this color right here. That point right there. So I'm going to tell you what point that is. It's the point 3, -2. 3, -2. So Ms. Johnson, you're saying that this point 1, 0 moved, got translated to 3, -2? Yes. Yes. So I'm gonna write that out really quick. So the point 1, 0, let me make it small again so I can make more notes here. So the point 1, 0 moved to the point 3, -2. The point 1, 0 moved to the point 3, -2. What do you guys notice? When I say that the point 1, 0 moved to the point 3, -2, I'm going to make that point 1, 0 there. How did it move? How did it move? Where did it move from? Like if you were giving directions to your friend who lives at point 1, 0 and you live at 3, -2, how would you say? Yeah, it went -2 down and 2 to the right. Exactly. It went 2 down and 2 to the right. Does everybody see that? If I blow this up a little bit, does everybody see that it moved 2 to the right, 2 down? Does everybody see that? Okay, so I'm going to give you some notes here. This moved 2 to the right. Oh, but Ms. Johnson, we already knew that it moved 2 to the right. I know, look, it's right here, 2 to the right, 2 to the right. So when you see this, eventually, not right now, but eventually I want you to get to the place where you see this and you're like 2 to the right. I know what that means. It means 2 to the right, right? Eventually you will see this right here. See the 0 in the Y spot? He moved 2 down, 2 down. So how does that show up? That shows up out here in the front or all the way in the back, not in parentheses. So I'm going to put him all the way in the front because I like him in the front, being clear that it is not part of the inside the parentheses. But Miss Johnson, wait, how come we had to change the X direction and made it its opposite? But down 2 literally means -2. How come you didn't change that one? Because why? Yeah, why doesn't live in backwards land? Why just, I don't know, why is a good little soldier, right? You say -2, it goes down 2, right? X is a little bit of a, he lives in backwards land. I don't know. He's reversed. Exactly. Okay, good. Okay, so my whole function is that, Miss Johnson? Yes. So eventually I should be able to read this as the whole thing shifted down 2 and right 2. Yeah. And then, so just to prove it, because I want to prove it, because I like proving things, because I like being right, right? And if you're taking a test, don't you want to be right? How would you check, right? So here, log base 2 parentheses x minus 2. Now, if you don't put that parentheses in there, Desmos is not going to listen to you. It doesn't know what you're talking about if you don't put that parentheses. So that's why I put that parentheses there. And if you look at this point right here at 3, -2, 3, oh, look, he's right there. Wait, try to get it perfect. 3, -2, I can't get it perfect. There he is, 3, -2, whew, right? So this function, this blue function matches exactly this one. And some of you are like, looks a little funnier, Ms. Johnson, just because the scale is different. The scale is different than this one, but it's the same exact curve. Do you notice your asymptote here? I sometimes call him asymptote because that's how you spell it. Your asymptote right here at x is equal to 2. Yeah. Do you notice your 1 point shifted over right here is at 3, -2? Do you see how the whole thing shifted down to? Yeah, you should have seen that. Okay. So eventually you could do that. Another way for you to check this is by plugging in your 3, and you better get out -2. So I'm going to try that too. Let me copy this here. I'm going to use my calculator because my calculator is my friend. I'm going to plug in 3 for x, and I better get out -2. Look, I got out -2. That means you're right. That means Miss Johnson, she's going to leave this alone because she knows that you explained this very well. And now it's up to you. Did you explain it very well? Then you'll get all your points, right? Okay, questions on this one? Okay, perfect. So 13 and 14, are you actually graphing it? I know that we can use, actually use the calculator here, but the point is to understand the movement of these. Okay, so yes, you can use a calculator. Can you just guarantee something? Ms. Johnson, if Ms. Johnson lets you use a graphing calculator, will she give you a question just like this? Probably not. Right? So what will she give you? She will give you a problem like this using the calculator. And then I would say something like, okay, now explain how you know that your graph is correct, right? And then, so I'm looking for language like it moved 2 down, 2 to the right. The asymptote is here, okay? So looking at this guy here, pick a variable, either X or Y, and tell me how they moved your original graph. So your original graph is still your log base 2 of x. So log base 2 of x, right? Your original function, that's your parent function. Pick a number and tell me where it moved to. Okay, pick a number and tell me how it moved. Someone said that -1 moved it to the right. Oh, that negative. Ooh, that sounds weird, huh? That sounds weird because -1 reminds me of negatives, which is to the left, which is really weird. But wait. That's right, because someone else told me that X lives in negative land. Oh, okay, that makes sense. Okay, so this means move right 1. Okay, so here's what I'm going to do. I'm going to take my graph and I'm going to start off with my 2 notable things. My asymptote at x is equal to 0 and my normal point at 1, 0. Right? According to this, I now need to move that point to the right one. Okay, so according to this, I need to move this point to the right one. See how I shifted just that point? Now, some people think, Ms. Johnson, when you shift a function, don't you have to shift the whole thing? Yeah. Or what I like to do is I just like to think about one point moving and then graphing it all together like that. Does that make sense? If I know how to move one point, I know how to move the whole function. Okay, so move right to right one. Yeah. Okay. So then this is no longer x is equal to 0. What is my new asymptote at? Where is my new asymptote? And I now want to change the color of this because I'm using this color. Yeah, my new asymptote, very fancy, is x is equal to 1. So here's my asymptote. Asymptotes are always drawn in with a dotted line. Ms. Johnson, why are they drawn with a dotted line? Because they're not part of the function. They're a helper to you drawing the function. Does that make sense? Very fancy. Some of you remember to do x is equal to 1. Very fancy. If you forgot, not a big deal. You wouldn't lose any points on a test. It's just, I'm trying to get you to talk like a mathematician because that's where I'm pushing you. All right, moving right along. Okay, so can you all see how the function's already looking? It's looking like this. Does everybody see it? Like something like that, right? Okay, then tell me what this 2 plus means. What does this 2 plus mean? Oh, it moves up 2. Okay, up 2. Okay, so can you right now take my 1 point and my asymptote and move it up 2 times? Move it up 2 times. People who are participating, even if you're participating at like 2 or 3 seconds after someone else, just because they type faster doesn't mean they're smarter than you. Just means they type faster. And just because you're faster at thinking about math doesn't make you smarter, by the way. It just means you think faster about math. Actually, the famous mathematicians that you guys would all say like are really brilliant in math, like Einstein or any of the other mathematicians, they're actually very slow thinkers. And the reason why they're slow thinkers is because they literally think of all cases. So if you find yourself like, oh, Ms. Johnson, I'm just a slow thinker, that's a good thing, not a bad thing. Because now you're thinking of all cases, right? Okay, so did you move your point up twice? And did you move your asymptote up twice? Yes, what's the new point? What's the new point? What's that new point? Where is it located? And don't be intimidated. Just write your answer. Even if someone already wrote that answer in there, who cares? Get your, remember, I asked you guys, I need you to participate at least 2 times. At least 2 times. Now, for those of you who are like, Ms. Johnson, I'm just retyping what someone else typed. Do it. Okay? Because otherwise, no participation means no participation. So you're hurting yourself in more than just one way, right? You're hurting yourself in the way called, now you're not getting those points, and you're hurting yourself in other ways as well. So just keep that in mind. All right, yes, the point is at 2-2. Very good, strong work. If you didn't get 2-2 until after the people got 2-2, your job is to say, okay, wait, where did their 2-2 come from? 2-2, get it? So the 2-2 came from here. Let me blow this up a tad so you can actually see it. So if I take this point and you all told me move it up 2, if I move it up 2, do you see how he's right there? He's right here now because he had to move up 2, right? And because he moved up 2, that coordinate is now 2, 2. So you're saying, Ms. Johnson, my point at 1, 0 moved to 2, 2? Yeah, because it moved right 1 up 2. Doesn't that make sense? So if you do the math on that, if you take a look at that, your point 1, 0 moved up to right 2, and it became the point 2, 2. Sorry, I said that wrong. Your point moved up 1. Bleh, sorry, your point moved right 1 now it's at 2. Up 2, now it's at 2 to give us that new point. Does everybody see that point? So from here, when I'm graphing, that's the only point I really graph. And then I just sketch my curve in there. Okay, it's not going to be a pretty curve because guess what? I'm not very good at drawing these curves. I'm going to draw it in a lighter blue so that that green still stands out. So it's probably too high, but that's okay. I'm okay with that. But it just needs to follow this curve. It just needs to follow this curve. This, just know on this side, it's getting increasingly closer to my dotted line, my asymptote. And this side is slowly growing up. I think I drew it too tall, but that's okay. I just need this curve. It's a sketch. It's not a perfect graph. Is that okay? So then I want to check my answer by plugging it in to my calculator, right? But again, I'm going to tell you again and again, this is not going to get you a lot of points on the test of you learning how to plug stuff into a graphing calculator. It's you plugging in points, not that exciting. So I got 2 plus log base 2 of x minus 1. I'm going to turn this guy off really quick. 2 log base 2 of x minus 1. I want to find that point. Turn this off. There you go. So look at that point right there. You guys all see my point right there? It's not showing up. There it is, 2, 2. Yay, it's at 2, 2. Even better yet, what you're going to do is you're going to plug in your point. You're going to plug in that point 2, 2. And I better get it. When I plug in 2 right here, I better get out of 2. I did. Okay, so things that I want to look for here, when I tell you to graph these things, I'm going to look for 2 things. Number 1, you're going to tell me where my asymptote is. Notice on my graphing calculator, here's my curve. Did it tell you where my asymptote is? No. So notice here how you are going to bring some knowledge to this. And then number 2 is, where did my 0.10 go to? So my 0.10 moved to 0.2, 2. So I'm going to need this kind of information from you so you can actually see, Ms. Johnson, I know how to talk logs. Okay, so for those of you who didn't get this, no problem. Look, there's another one for you to try. So right now, what I would like you to do is I would like you to try this. So pause, try this, and tell me the 2 things. Where did my asymptote go? And where did my 0.10 go? Okay. Okay, so I asked you to graph this, and I said, all I want you to do is tell me where the 2 things move to, asymptote and the 0.10, right? Because those are the defining points of our log function. So I want to know where those move to, because those are going to be the defining things that I look for on your sketches, right? So here, the very first thing I'm going to do is, okay, I want you guys to talk about this +2. What does that +2 mean? What does that +2 mean? Yeah, very good, very good. So that +2 means left 2. Very good. Very strong work here. I have a bunch of people answering my chat. Very good. The next part is, I like that some people are still saying, hey, Ms. Johnson, it's negative, right? Yes, we move to the negative side because, again, X, he lives in, what is it called? Backwards line. Okay, so this means left 2. So everybody gets shifted to the left 2. So can you imagine your original point right here is at 1, 0. Can you imagine your asymptote right here is at x equals to 0? If I shift this point to the left 2, where is he at right now? If I shift him to the left 2, where is he at right now? Very good. Yes. Very, very good. Yeah, he's at -1. Exactly. Okay. So the next part is, okay, so now I have him here, right? That's where I moved him. I moved him left 2. Right. I'm not going to write. Oh, maybe I will write left 2. Left. Oh, it looks like a smiley face. Look how cute that is. Oh, he's cute. Okay, sorry. X is equal to 0. If I move my asymptote twice to the left, where is he at now? Very good. Yes, exactly. Okay. So now he's at x is equal to -2. So I'm going to draw my dashed little line in there. So x equals -2. So my asymptote is x is equal to -2. Notice this is how you spell asymptote, asymptote. That's why I say it like that. So now let's deal with this -1. What do I do with this -1 business? What is he telling me to do? What directions is he giving me? Down 1, exactly. The whole function moves down 1, exactly. Very good, very good. You guys already, I think you guys already know what questions I'm asking and you're like anticipating it. And then you put it in the chat. That's actually very strong work too. Okay. So move down 1, Miss Johnson. Yeah, I moved down 1. So he's right there in my little smiley face, right? Okay, look. So if you take your asymptote, see this line right here, and I move him down 1, did anything happen to that asymptote? Look, here's my line. I moved down 1. Does this line change, or is it still x is equal to -2? Yeah, it doesn't change. It's still x is equal to -2. Exactly. So for those of you who are like, well, why, Ms. Johnson, why doesn't it change? It's like if you take your pencil and you point it to the ceiling and you moved it straight up, it's still on that same line. So asymptote is 1 left from the point of 1, 0. Yes, your original asymptote for your log function, turn this guy on. The original asymptote for your log function is at x is equal to 0. Yeah, to the left of the point 1, 0, exactly. Okay, so then I'm done. Yes, I'm done. So down 1. So then I would just draw my curve in like this-ish. And then you would have to tell me where that point moved. So the point went from 1, 0, 2. Now again, if I moved left 2, it would be -1. Down would be -1. So -1, -1. Okay. So these are the 2 pieces of information that I'm going to be looking for on your quiz. Like, where did the function move to? Notice number 1, it's not something that your graphing calculator can tell you. So again, Ms. Johnson, how come you let us use a calculator? Because I'm not as impressed of you putting something into a graphing calculator as you pulling information out of that graph, right? Okay, last question. It says, compare the transformation of the graphs of log functions with the transformations of the quadratic functions. What similarities and differences do you observe? We talked about this up here. Oh, so okay, sorry. Someone asked in the chat. They said, hey, Ms. Johnson, where did the point -1, -1 come from? Can someone explain where would we get this -1, -1 from? What would you tell someone to say, hey, where did that point -1, -1 come from? When you translate, okay, but you got to put it to the public chat. When you translate the graph, okay, but what would you tell them? From the translation that happened to log base 2 of x. Okay, so our original point was at 1, 0, right? So if you look at this, sorry. So the original point is right here at 2, 0. I mean at 1, 0, right here. So, and then I'm going to follow these directions, right? So we start at 1, 0, someone said, and then we moved left 2 and down 1. So if you move this point left 2, see it's right here, down 1, now it's right there at -1, -1. So someone else said, and I'm going to put these in here. Sorry, let me cut these real quick. So someone put this in here. Oh no, you're not gonna let me. Oh, there it goes. Oh. Oh, it's right here. Sorry. So when we start at the point 1, 0, and we move 2 to the left and 1 down, it makes it negative. Oh, it's up here. Where are we? Where in the world? Yeah, right there. Oh no, it shifted everything. Erg. Hold on. There it goes. Ooh, that's bad. Oh man. Yay, there it is. Okay, sorry. Okay, there you go. So let me put it where I want it again. Right here is probably a good place. So someone said when we start at the point 1, 0, we move 2 to the left. And this is why we move 2 to the left and 1 down. We move 1 down here. So think about these as directions, right? Think about these as directions on how to get to your buddy's house, right? Very good. Great directions. Great explanations from that. Awesome work. Okay. Okay. Last question. It says, compare the transformations of graphs on log functions with the transformations of graphs with quadratics. What are the similarities and differences you observe? So if you remember, this is all the way back in the jumpstart problem that we started all the way up here. We spoke about like the transformations. This is not even it. It's up here. Here it is. It's these transformations, right? And we did this here, and we did this. What similarities are there? Great question, by the way. What similarities do you have between the transformations on this and the transformations on our logs? Is it the same? What things do you find similar and what things do you find different? Anybody? So no. So a quadratic does not have an asymptote. No, not really. Okay. I don't think you guys understand. It has to do with, okay, let's go back up here. Let's go back to jumpstart really quick. So the jumpstart problem, x squared looks like a curve, looks like this red curve right here, right? And then this second one is the blue curve, right? What shifts did it make? What shifts did this thing make from here to here? Yeah, there was a reflection. Good. But talk about the shifts. Yeah, it went 3 up, 1 left. How did you know it went 3 up, 1 left? Is that the kind of shifting that is the same, or is it different than these kinds of shifts here? Yeah, it's the same. So what they want you to answer here is the translations, whether we're talking about left and right, up and down, it's the same. So once you understand transformations on a function, it doesn't matter which function I give you, all the transformations will be the same. Inside the parentheses, meaning it's happening 2x, then it's going to be in backwards land. So +2 means left 2. I don't know how to spell left. Look, left 2. Huh. Okay. Outside of the parentheses, it's happening to the whole function of log. That's happening to the y. So it's down 1, right? So that's what they actually wanted you to get out of that. Got it? So transformations on any function, and this is true for the most part for all your families of functions.